Okay, we are going to keep working in chapter 5 this week. And we're still going to be working on our systems of inequalities. So we're going to be graphing a bunch today. Oh my. All right. We are now going to graph multiple slanted lines and shade accordingly. So pretty much what we had before was just one line we shaded, except for in the case of when we were only working in the first quadrant, we did show a little bit of how we only then shaded in the first quadrant based on the additional pieces of information that we had with x greater than or equal to 0 and y greater than or equal to 0. So what we're going to do now is I'm going to do line by line. I'm going to see where its shaded region falls. And then in the end, we are going to shade the overlapped region as the final solution. So the first one I have here is 3x plus y is less than or equal to 21. So on the side, I'm going to subtract the 3x to the other side. So y is less than or equal to 21 minus 3x. That means I'm going to start up at 21. I'm going to go down 3 and over 1 repeatedly, as many times as I can. Now, I know I've said before, you technically only need 2 points to create your line. However, when we're working with these systems, it's best to have more points along the way because you're going to need to know where these two lines intersect. And if you have all the points along the way, then you'll be able to have the correct intersection easily found. Less than or equal to means it will be a solid line. And then the less than part means I'm currently going to shade below the graph. Now, I'm lightly shading currently, and I will usually go like a horizontal and then vertical so that I can see where the two intersect for the final answer. So however you want to kind of distinguish your two shadings, if it's two colors, however you want to do it. Second line, x minus 2y less than or equal to 0. So I'm going to subtract x over. Negative 2y is less than or equal to negative x. And then I need to divide through by negative 2, which is going to flip my inequality sign. It's going to be greater than or equal to positive 1/2 x. All right, I'm going to start at 0, the origin. And then I'm going to move my slope up 1 over 2 and repeat that until I see I did cross exactly at a nice point here. I will draw my line, which is solid. And then for this one, it's greater than or equal to, so I'm going to shade above the line. Now, I purposely do horizontal and vertical so you can see where they cross. And that is where I'm going to do my final shading. Which is over here. So this is the final shaded solution area. Everything else, like I said, is lightly shaded just to show, hey, this is my work along the way. darkest shade should be your final result when you're done. All right. As we go through these, we got one more here. We'll do this one and then we'll talk about corner points. So x minus 2y less than or equal to 12. So x minus 2y less than or equal to 12. So I'm going to subtract the x over. Negative 2y less than or equal to 12 minus x. Got to divide by the negative 2, which is going to flip my sign. It's now going to be greater than or equal to negative 6 plus a half x. So I'm going to start down here at negative 6 and then go up 1 over 2. It's again going to be a solid line because it is the equals to. And then this is greater than or equal to, so I'm going to shade or lightly mark above the graph. Second one, 2x plus y greater than or equal to 4. So if I solve it for y, grab your paper. Subtract 2x over to the other side. Y is greater than or equal to 4 minus 2x. So this one's going to start at 4. And then I'm going to go down to over 1. And then once I intersect my other line, then I can make my line. It's going to be solid. Okay, and we want greater than. So greater than is always up and to the right. So up. If your line, like it was easy with the first line, above it was above it. Sometimes when this slanted line is downward sloping, it's a little hard to think of, okay, where's greater than? The other way to think about it is go to your y-axis. Y's are greater up here. So this is where I would be shading for the green line. And then in the end, they overlap in this section here. So when we graph these, we're going to get two scenarios. One is bounded or unbounded. And then regardless of which one we have, we also have corner points. So a corner point is going to be the intersection of two boundary lines. So this is why I specifically stated back here, you want to do as many points until the two lines intersect, because this is a corner point. And if you're not graphing all the points along the way, you're not seeing a corner point. And then your line can be off, because if you're not graphing exact points along the way, you may not see that this is at exactly, what is this, 2, 4, negative 4. It may look, if you're not careful with your lines, it may look like it's at a different spot. So that's a corner point. Now, bounded means it's going to be a fully enclosed area. So this is what your quick quiz was at the end of last class. We had a line here, and the shading was contained between the line and the two axes. That's considered a bounded area, right? There's a bound on every side. There is a boundary line that the shading area does not cross. So unbounded is then going to mean that it's going to continue the shading forever. And that's what happened in the first two examples we saw today. So you've got a line here, you've got a line here, and the shaded area is above here. Now, because these lines continue forever and ever, up and up and up, that shading is going to continue forever up and up between those two lines. So there's no boundary along the top that is going to contain that shaded area. Make sense, the difference? So now we are going into the part of, after we graph these, are they bounded? And then can you find all of your corner points? So here's our next two problems. We have 3x plus y is less than or equal to 6. X is greater than or equal to 0. Y is greater than or equal to 0. So these right here automatically tell me I have to be above this axis and to the right of the y-axis. So if we work with this first guy, 3x plus y less than or equal to 6, and I solve for y, if I subtract 3x to the other side, y is less than or equal to 6 minus 3x. So I'll start at 6, down 3 over 1, down 3 over 1. I'm going to continue my points until I intersect both lines. So I intersected at 6, I intersect down here at 2. Less than or equal to means this is going to be a solid line. And then I'm going to shade below the line. So I need to go below the line such that it's still in the first quadrant. So that shading is just going to be this triangle here. Because it is enclosed in a triangle, it is bounded. Because it is a triangle, it has 3 sides and 3 corners. So corner 1 up here is 0, 6. Corner 2 down here is the origin, 0, 0. And corner 3, 2, 0. Next one has 4 inequalities. Negative x plus 2y is less than or equal to 2. Negative x plus 2y less than or equal to 2. So I'm going to add the x to the other side. 2y is less than or equal to 2 plus x. And I'm going to divide everything through by 2. So y is less than or equal to 1 plus 1/2 x. So I'm going to start at 1, up 1 over 2. And I'm going to repeat that just because I don't know how far I have to go for my intersection of my next line. For this one, we want less than. So that's going to be shaded below here. All right, next line, 2x minus y less than or equal to 2. 2x minus y less than or equal to 2. So I'm going to subtract 2x over. Negative y is less than or equal to 2 minus 2x. And then I got to divide everything through by negative 1. It's going to flip my sign. So y greater than or equal to negative 2 plus 2x. So I'm going to extend my graph down here. Negative 1, negative 2. Then I'm going to go up 2 over 1, up 2 over 1. Okay, I found my intersection point there. And that's why I say to be careful with your line, because you can see that I totally got off my slope there. Did not make a very nice straight line. So this one wants greater than, so we're going to be shading above the line here. So we're at negative 2. Y is greater, we're going to be up this way. So far our shaded area is down just in this lower left corner. However, it also tells me that x has to be greater than or equal to 0. n. So I can't have any negative x's. So that's a limit. And y has to be greater than or equal to 0. So this is also a limiting factor here. So what I have for my final shaded region is this tiny little kite down here. And because there are 4 lines, there are going to be 4 corners of my kite. So this is bounded. The final shaded area is contained between lines. And my corners are the origin 0, 0, up at 0, 1, across at 1, 0, and at the point 2, 2. Question so far? Yes, Steve.
In the first one, corner 1 was the 0, 6, and the second one it was 0, 0. They're different from what we.
Oh, it doesn't matter.
Okay.
No, I just went around like this. You just label them all. That's all that matters. Doesn't matter which one's 1, 2, 3, 4. Just know that if there's 3, list all 3. If there's 5, list all 5. Whatever you got. So if we look at this guy, we started with 3, then we went to 4. Now this one has 5. So 2x plus y is greater than or equal to 16. I'm going to start with that one. 2x plus y greater than or equal to 16. So other way to work on these, remember, is that you can do the intercepts. So 2 times 8 would give me 16, which means I'm going to cross the x-axis at 8. And if I get rid of the x, that's y is 16, so I know it's going to be over here. The only thing I would then need to do is figure out the slope, which is when it's in ax plus by equals c form, the slope is the opposite of a over b. So in front of the x is the a term, which is 2. So 2, opposite of 2 is negative 2 over 1. So down 2 over 1 should give me my slope all the way across there. Because y is positive, I'm not going to need to change my symbol. So it's going to be greater, which is up here. Again, I'm going to do very, very light shading to get started, just because we've got a lot of lines that we're going to graph here. So for this guy, x plus y greater than or equal to 12. Well, that's going to intersect at both 12 and 12. And then because both x and y are 1s, slope is going to be the opposite of 1 over 1, so down 1 over 1. So I'm going to mark that one a little bit bigger just because it's currently intersecting that line. And it may be a corner point. I don't know yet because I don't know where my other lines are going to fall. But it is an important point at this point. Okay, y is positive, so we're not going to switch the sign. Again, it's going to go above. So we're currently shaded up there. X plus 2y greater than or equal to 14. All right, so if I solve that for x, getting rid of the y, x is 14. Y is going to be 7 because 2 times 7 is 14. And then the slope opposite of 1 divided by 2. Down 1 over 2, down 1 over 2, down 1 over 2. Okay, this is outside of the final shaded region because I have to be above the red line. So while it's above the purple line, it's not also above the red. It's not also above the red line. So this point won't matter. But I'll keep going down 1 over 2, down 1 over 2 until I intersect. And we want to be greater than this line as well. So we want to be above the blue line. So currently what it's telling me is we need to be above all 3 of these lines simultaneously. Okay, so you can see here, there's a little bit of shaded blue, but that's not in my shaded region. This has both blue and red, but it's not in my final shaded region. I need it to be above blue, red, and purple at the same time. Also noting that everything's going to be positive, okay? So I cannot go past the x-axis. I cannot go past the y-axis. So I need to be above the purple line and the red line and the blue line at all times. So that is going to be like a color I didn't use yet. All right. I'm above the purple line. But now the red line becomes the top one. Then the blue line becomes the top one. And then I have to stay above the x-axis. So this is my final shaded region. And you should see that as I'm shading over here, I have both the purple, the red, and the green lines all in this shaded area. So that's how I know this is my final answer. Now this one, unlike the other 2 we've done, is unbounded, okay? There is no top limiting top. There is no right-hand limiting factor here. So this is unbounded. And then here's my corners. So this one is 0, 16. This one here is 4, 8. This one here is 10, 2. And this guy over here is 14, 0. We're going to end with 2 word problems. Manufacturing company makes 2 types of water skis, a trick ski and a slalom ski. The trick ski requires 6 labor hours for fabricating and 1 labor hour for finishing. Okay, I already got enough information here. So trick, slalom, fabricating, finishing. So let's see. The trick ski is 6 hours of fabrication, 1 hour for finishing. The slalom is 4 hours fabricating, 1 hour finishing. The maximum number of labor hours available per day for fabricating. Okay, so total here, max total, 108 and 24 respectively. If X is the number of trick skis, and Y is the number of slalom skis produced every day, write a system of linear inequalities that indicates the appropriate restraints on X and Y, and then find the set of feasible solutions graphically for the number of each type of ski that can be produced. All right, so we've worked with real world problems where we move the data into a table and then turn it into our equations. Now, in this case, it's going to be inequalities though, because I cannot go above this because it is my maximum. So if I put these X and Y's in here, 6X plus 4Y, my maximum is 108, so less than or equal to 108. Second equation, X plus Y less than or equal to 24. Because we are working with real world problems, X has to be greater than or equal to 0, and Y must also be greater than or equal to 0. Now, you can see for this one, I clearly did not give you a graph, so we can show you again how to do all of this in Desmos. All right, so 6X plus 4Y less than or equal to 108. I'm going to do each one separate and just show you how the shading overlaps. X plus y less than or equal to 24. X greater than or equal to 0. Y greater than or equal to 0. So you're going to see there's a whole bunch that's going on here. All right, working one at a time. So red, shaded below the line. My next one is blue, so now it's shading below both of them. But now I have to be greater than x's and greater than positive x's, positive y's. So what you can do is once you've graphed all of these, you can actually I don't want to do that. Sorry, I hit the wrong value. Copy this one. We'll see. Okay, copy it. And your curly brackets. Copy this one. And then these ones are a little easier to type. X greater than or equal to 0. Y greater equals 0. And then you can see that really, really dark shaded region is the final solution there. So then it's really easy to go back and I could just change that to equals if I wanted that line to show so that I can find, label that point. Make that an equals to, graph it again. There's a corner point. This is another corner point here. And then I need to change these to equals. So that I can get that corner point down there. Is it going to give it to me? There it is. And then you can see all of my corner points are marked on my graph. And if you want, if you click the little label, it'll actually put them on the graph instead of on the side. So I always put the initial inequalities in so that I can copy them when I want to make my single one that does my final shading for me. And then I just go back and change all of the inequalities to the equals so that I can get those corner points to show up on my graph. So bounded, it is a quadrilateral, a four-sided shape, and we have our four corners. All right, last one for today. A dietitian in a hospital is to arrange a special diet using two foods. Oh, all right, so each ounce of food M contains 30 units of calcium, 10 units of iron, and 10 units of vitamin A. So I'm just going to start putting it into a table here. Each ounce of food N contains 10 units of calcium, 10 units of iron, and 30 units of vitamin A. The minimum requirements in the diet are, so minimum total. So now this one is a minimum. This one back here was a maximum. So minimum means we're going to use the other symbol. 360 for calcium, 160 for iron, and 240 for vitamin A. If X is the number of ounces of food M, and Y is the number of ounces for food N, write our equation, our system of inequalities, and then we're going to solve it. So x, y, all the way down, we have our equations. So 30x plus 10y is now greater than or equal to 360. 10x plus 10y greater than or equal to 160. And 10x plus 3y greater than or, 30y is greater than or equal to 160. 240. So just to know the difference, the last one, they were all less thans. And we had a nice little, so our 2 lines less thans, and then our limiting factors, x and y, kept it in the first quadrant. So we knew it was going to be below those 2 lines. When we're working on this one, though, oh, let me add my x greater than or equal to 0, y greater than or equal to 0. When they're all greater thans, we're going to have an unbounded and it's going to shade up. Okay. So one at a time. 30x plus 10y greater than or equal to 360. 10x plus 10y greater than or equal to 160. 10x plus 30y greater than or equal to 240. We have x greater than or equal to 0, y greater than or equal to 0. All right, so do them all separate so that I can take the first one, paste it, and then I'm going to paste all the remaining ones in curly brackets. X greater equals 0, y greater equals 0. Okay, and then I'm going to go back and change these to just equals. All right, so there is my shaded region. Okay, so this point here is on a corner. This point here is a corner of my shade. That one here is a corner of my shade. And then I gotta go, oopsies. There it is, this guy up here. Add it, label. Yeah, I'm gonna zoom out just a smidge. There it is. So anything in the shaded region would be a solution. So I could pick any of my corner points would be a solution. Any point along this blue line would be a blue line between 0.36 and 10.6 would be a solution. Anything on the purple line here between 12.4 and 24.0 would be a solution. So I could have like 10 ounces of both foods would work. I could have, this one will be 24 ounces of only food M, nothing from food N. So 24 ounces, though, is more food than doing something like this, 10 and 6, right? That's a total of 16 ounces of food. So 16 ounces of food versus 24 ounces of food. may make a difference. Are you still getting what is required? Yes. Yes, question. So I literally, they're all in a line together in inequality form. So you write the first one as is, and then every successive one after is in curly brackets. So all four of these are in the curly brackets following the first one. I lost my cursor. Hold on. It's over here. That's what I get for having two screens. So you can see here, this is the second equation in curly brackets. This is the third equation in curly brackets, fourth, and then the fifth one. And that's how you get all of it to do just one shade. Oh, did you uncheck your other ones? Unselect. So like on the side, unselect these, and then so just click a circle. If you click the actual circle, it'll remove those shades and only leave that one. Yes, that's your final shaded solution. Yeah, I like to put the lines, I like to keep the lines in just because I can then click on the lines to see the points. Otherwise, you're just zooming in to be able to figure out where those points are, or you can like click them on and off. But if I clicked all of these off here, then it shows just the shaded region with my points.
Did you go in and put those back in manually?
No. So by having the lines there, all I have to do is click on the intersection and then a little button pops up. So I'm just going to pick another point over here. This isn't one of the intersection points, but if I click it and I hold it there, if I click this button here, it says export point to the list. So that goes here. And then if I want it to show on the actual graph, I click label it on the graph. Because it's not a corner point, I'm not going to have that one saved. But if I wanted to later just say, I wanted to have an extra solution like in the shaded region, I could just add any point. So let's say 12.8 would be a point in the shaded region. So I could do that. And then I can manually type them in. It's up to you which you prefer. So if they weren't shown, all I would have to do is like when I go up here, they're all still being labeled. So give me a second. So if I didn't have any of this stuff and I only had my shaded region, what I would do is I would count and say, okay, they're counting the scales by twos. So this is 12 to 4. So then I could just come over here and actually type it 12.4. I've never seen that before. 12.4, comma, and then I can label it myself. So it's just preference. I prefer to use the lines that are there and just find their intersections because to me that's faster. But either one will give you your corners. And when we're working with multiples like this, Desmos is great just because there are so many pieces to shade, especially when you have like 5 lines like this. Definitely use the technology to help you in that final shading. That is all I have for today. There is no quick check today. I did grade everything from last week. So if you did not do well on one of those quick checks and you want to go back and fix something, you do have some time now to do that. Heads up that next week is your first test. So we'll talk about that later. Don't have to talk about it quite yet. The first test will be though on chapters 4 and 5. So we have 5-2 that we did today, and we're going to do 5-3 on Thursday, and then we are done with chapter 5. It'll be online. Yeah, well, I'll talk about it next week on Tuesday and then explain all of those pieces.